So today we're going to continue with our law of sines, law of cosines, and the second part of this would be the law of cosines. Law of cosines is going to be another way that we can determine sides or missing angles in a non-right triangle, just like you did with law of sines previously. Again, the triangles that we're going to use for law of cosines, none of them are going to be right triangles, either acute or obtuse triangles, and that's how we're going to find missing sides. So first and foremost, here is the law of cosines. There's three equations, and the equations are going to vary depending on which angle you're given. You notice that each one of these ends with cosine of an angle. So you have cosine of A, cosine of B, cosine of C, and depending on which angle you're given or which angle you're trying to find, angle A, B, or C, you're going to use each one of these equations. So my first example, I want to find out what A is, and as you can see, I'm given angle A is 75 degrees. So I'm going to go ahead and use the first equation that's listed above, and that's for my angle A. A squared equals B squared plus C squared minus 2 times B times C times the cosine of A. Now let's go ahead and write all my variables out here. So I have all three sides. I've got A, I've got B, and I've got C, and I've got angle A. We can go ahead and fill in what we know. We know angle A is 75 degrees, so I can go ahead and put that in right here. As far as my sides are concerned, A is the side that we're looking for. We don't know what that is, so let's put a question mark here for now. B is going to be located across from, here's angle B, so across from angle B is going to be 29. And then C is going to be located across from angle C, or 25. So now that we've listed all our variables and the values, let's go ahead and plug this into the law of cosines equation. So it's going to be A squared. So A, again, we don't know what that is, so A squared equals B, which is 29 squared, plus C squared, C is 25 squared, minus 2 times B, again, which is 29, times C, which is 25, times the cosine of angle A, which is 75 degrees. Now this may seem like a lot written out here, 29 squared plus 25 squared minus 2 times 29 times 25 times the cosine of 75, but there's really no other operations over here. There's nothing I need to get by itself. I want to solve for A. So this entire part on the right hand side of my equal sign, I can just plug into my calculator. So let's bring our calculator up. Now we're going to plug this into our calculator the exact way it's written. Notice I put everything in parentheses, so let's go ahead and do the parentheses and plug it into our calculator as well. So I'm going to say parentheses 29, close my parentheses, squared, plus parentheses 25, close those parentheses, oops, parentheses 25, close those parentheses, square that, minus 2, parentheses, 29, close parentheses, new parentheses, 25, close those parentheses, times cosine of 75. Go ahead and close that as well, and I'm just going to press enter. So the number I get here is 1090.712385. We'll go ahead and round to the nearest hundredth, so we'll say 1090.71. So that's what I get when I simplify the right-hand side of the equation, and it's equal to A squared. So we're not done until we get A by itself, so in order to undo the A squared, I'm going to square root both sides. The square root and the squared are going to cancel, so I take the square root of 1090.71, and I'm going to get approximately 33.03 for the length of A, rounded to the nearest hundredth. Now reading the directions for example 2 says find the measure of a missing angle in a triangle. Find the measure of angle A. So this one's different from the previous problem where I was finding a missing side. Now I'm finding a missing angle. But like I said earlier, as far as which equation I'm going to use, it's going to depend on which angle I'm looking for. Since I'm looking for angle A, I'm going to use that first equation again, like I did previously, where it's a squared equals b squared plus c squared minus 2 times b times c times the cosine of a. And again, like previously, I'm going to go ahead and list my variables. I've got my three sides, a, b, and c, and I've got angle a. So again, side A is going to be the one that's across from angle A. In this case, that's going to be 6. B is going to be across from angle B, or 9. And then C is going to be across from angle C, which is 14. And then A is my unknown for this one, so I don't know what angle A is. So the next part of this is let's plug everything into the equation that I have written above here. So it's a squared, a is 6 squared, equal to b, which is 9 squared, plus c, which is 14 squared, minus 2 times a, which is 6 times, 2 times b, which is 9, times c, which is 14, times the cosine of a. But again, I don't know what a is. So this one's a little bit trickier than the previous problem we just did, and we're going to need to simplify. Let's break this down into 3 parts. There's the 6 squared right here. There's 9 squared plus 14 squared. And then you've got this negative 2 times 9 times 14 times cosine of a. And we're going to do each one of these parts individually and just kind of break them down. 6 squared we know is 36. For this next part, the 9 squared plus 14 squared, we can go ahead and use our calculator for this. Just type in 9 squared plus 14 squared. Gives me 277. And then I'm going to do minus negative 2 times 9 times 14, which is negative 252. Times the cosine of a. Now it's really, 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 really important, and I'm going to go ahead and highlight this right here. This area Now, a common mistake that people are going to want to make here is to do 277 minus 252 and say it's going to be 25 cosine of a. But we need to remember here that these are not like terms. We have a variable a over here on the right-hand side. So here's my variable right there, which is a. So this is essentially kind of like a problem where if you were doing this like a regular algebra problem, like 2 plus 3x, you would not put the 2 and the 3x together because they're not like terms, because that's a variable right there. So same idea, I can't have this a by itself over here because the a is a variable and I can't just combine unlike terms. So the next step in this problem is going to be we need to subtract 277 from both sides. So subtract 277 right here, subtract 277 right here. This is going to cancel out. 36 minus 277 is going to be negative 241, and that's going to be equal to negative 252 cosine of a. So we want to get rid of the negative 252 in front of the cosine of a. So to undo multiplication, I'm going to divide each side by negative 252. These are going to cancel, and I'm going to get, we'll round to 4 decimal places, so 0.9563, and that's going to be equal to the cosine of a. Now we want to undo cosine, so we need cosine to go away. So if you remember from our previous lessons, we're going to take the inverse cosine of both sides. On the right side, he's going to cancel out and left with just a. And on the left-hand side, take the inverse cosine of 0.9563. Press enter, and I'm going to get about 17.0. We can go ahead and call this 17 degrees for my answer. and then go ahead and make sure we label with degrees. So the measure of angle A is going to be 17 degrees. So we found one side, we found one angle. This example 3 wants you to solve the right triangle. So we need to find both missing angles, angle A and angle C, and then our missing side, AC, which would be the opposite of angle B. So go ahead and pause the video right now. Go ahead and try this on your own. Try to find the measure of angle C, the measure of angle A, and then go ahead and find the the length of AC. All right, so we get B equal to 29.68 approximately. This is going to be in meters. And then angle A is going to be about 42.29 degrees approximately, and the measure of angle C would be about approximately 47.71 degrees. So that's it for law of cosines, and if you have any questions, make sure you write them down on the side and ask them in class next time we see you. Have a good day.